Okay, so again, good afternoon po to everyone, especially our dear students or attendees for today's webinar, and most especially to our, pwede na ba nating tawagin Ma'am Lindang partner, ang OneWatt? Sige, I'll introduce them as one of our partners, OneWatt, with Ma'am Marika and Sir Paulo, fresh from South Korea. Diba? That's nice. But anyway, before we start with his talk, let's start with the opening remarks to be led by Ma'am Denise Luby Punsalan, to be followed by the Philippine National Anthem, Olongapo City Hymn, and Gordon College Hymn.
Ma'am Denise, wala kang audio?
Okay, ma'am. Dinownload ko muna because wala pala si Sir Ray, so I'll be the one who will be presenting two. Okay. Sige
Okay.
po.
Lord, thank you for this day, for the presence of everyone in this call. For once again, we are gathered and given the opportunity to appreciate life and your words. Forgive us for our shortcomings and cleanse our hearts as we learn and live your words and example. Father, bless our endeavors, especially today's meeting. May you guide us in our discussions, and may you enlighten our minds in every decision that we make. Give us your grace that we may effectively do our parts for your greater glory. All this we ask in Jesus' name. Amen.
Mga kababayan, ang pambansang awit ng Pilipinas.
Lungsod na mapayapa, lungsod na marangal, sa perlas ng silangan, bayani ang mamamayan. Mga sakit sa bayan, sa puso'y nagnunulay, ipinagbubunyi, Olongapo po aming bayan. Kapwa-tao at volunteerismo, lungsod na maulay, may kapalaging mo. Lungsod na makulay, may palaging gabay. Sama-sama bawat oras, sa pag-unlad, Olongga po ang bayan, ika'y aming tanglad.
The sea breeze over Subic Bay, while the rain waves to mighty rest. Sets our voice inspiring ways, aboard the knowledge made us blessed. Raise our voice in silence, sing the praises in cadence. Let these follow our daily life, and we send the pilgrimage. Bless our alma mater, keep her firm and strong, and be able to mold us all. Set us upright on the road, hear the echo of her song, feel the warmth of her voice, keep the flame of the torch. At Gordon College proudly we belong.
There you go. So to get us going, let's introduce, without further ado, our College Dean, Dr. Erlinda Casela Abarintos, for her opening remarks.
Okay, good afternoon to everyone, especially to our guest speaker and also our partner, OneWatt, which was introduced to us by Miss Marika. Miss Marika Roldan na siya ngayon. I have the honor to meet Miss Marika when she was still a student pa noon. She helped us organize one of similar events like this, and since then until now, she never failed to connect with Gordon College through me if ever there would be opportunities like this. So thank you, Miss Marika, for that. For always considering Gordon College to be beneficiaries of all your efforts for IT education. So yun po yung ano namin with Miss Marika. And I know all our students, upon saying that Gordon College hymn, I know you've been missing our school campus. For the information of Mr. Paulo and Miss Marix, it's been more than a year since the pandemic started. We have been meeting our students face to face. So since mid-March 2020, we have been conducting our classes online, and probably until the end of this year. I don't know what will happen next year kasi currently our school building is being used by our local government unit of Olongapo City, because Gordon College is a local college. That means it is a public college here in Olongapo City. So it is being used right now as a isolation facility for COVID-19 patients kasi limited lang yung facility ng aming local government unit. So since one of the convenient place or venue where the government can temporarily assist yung mga COVID-19 patients, so kinonvert muna into isolation facility yung aming school building. Kaya nakakamiss din when I saw that Gordon College hymn, talaga nakapokus siya doon sa aming facility. So that is where our school is located. When Marix visited us before, it was from the previous location pa, yung aming unang yung unang building namin located in Old Hospital Road, which is now converted into SM City Olongapo Central. Hopefully, Marix, I don't know if you've seen that, if you have visited Subic and Olongapo after that visit you had with us. Pero now, it has been converted into SM City Olongapo Central building. And because of that, SM City uh, donated that building. Yung nakita nyo kanina na Gordon College building, that was donated to us by SMCT. Okay, so yun yung background there para at least Paulo would know what Gordon College is, how we are right now. And syempre, I would really like to take this opportunity to thank nga OneWatt for considering Gordon College as one of the beneficiary of this talk. I know you would be conducting a series of this in different colleges and universities, and thank you for considering Gordon College as one of your possible future partner. So for the information of everyone, and I think Mr. Pau would also be discussing this, OneWatt is a company based in Netherlands. That's what Pau informed me earlier, and they are in the process of exploring or are setting up their office here in the Philippines and to partner with other industry in the Philippines. And I know some of you would probably be the first time to hear about what anomaly detection is. Actually, this is also the first time I heard about uh, that uh, computing concept, anomaly detection. When Marix informed me about that, I really got interested kasi it's a new topic, okay? And I hope that after today, we will really be able to have a grasp of what anomaly detection is. And I checked on the net, Techopedia says it's mainly a data mining process and it's used to determine the types of anomalies occurring in a given data set and to determine details about their occurrences. So basically, yun yung what anomaly detection is. And for further discussion on that, that's what Mr. Paulo will be presenting to us later. Okay, so I hope everyone would be listening to what Mr. Paulo Samontanes would be talking about anomaly detection. And then if you have any questions or queries or comments, you may type that in our chat box so we can discuss that later, because after Mr. Paulo Samontanes talk about anomaly detection, we would have a portion to entertain any questions or queries from our participants. Okay, and I think to end this opening remarks, I would just like to share a quote from Mr. Devin Wenig, a CEO of eBay. He said, if you don't have an AI strategy now, you are going to die in the world that's coming. So it's really very important for us to be informed, to be updated of what possible artificial intelligence strategies we can get so we can be ready for what is coming. Okay, so again, good afternoon to everyone. And to introduce formally our resource speaker, I would like to request the honor of Miss Marika Roldan to do that. Good afternoon po to everyone.
Thanks, Miss Linda. And we're very honored to be for you guys to host our Rise of the Machines too. Anyway, sige, so I would like to introduce my colleague in OneWatt, Mr. Paulo Samontañez. So he's one of the co-founders and chief technology officer of OneWatt, and OneWatt is a startup that predicts motor failures using sound by literally listening to the sound coming from these assets. So he has been working with and have founded startups since 2010. And after realizing that he cannot achieve world domination without a corporate job, so so with his startups, he made contributions to society by making cow milk tastier with the use of IoT, analyzing foot traffic in establishments to improve sales, and securing remittances globally for corporates and OFW. So right now he spends most of his time understanding how motors talk, and he's in South Korea right now. So without further ado, let's give him a virtual round of applause. So, yeah. Welcome. Hi, Pao.
Hello.
Thank
Good
you.
afternoon. So, are you guys ready for a bit of math and a bit of TS stuff?
Yes,
Okay.
sir, we're ready.
Okay,
Very much
let me
ready.
start by sharing my screen. Share screen. Can you guys see my screen now?
Yes, sir.
Yes.
Okay. So as Ma'am Erlinda and Marix mentioned, we'll be talking about mainly anomaly detection. So today I'll be going through what it is and why should we be adopting this technology. What are the specific use cases of anomaly detection? Where is it good at? And then after that, we can go through some of the key algorithms that you can use to start your anomaly detection journey. And then I'll be going through some notable applications where it is being used right now. And then finally, a conclusion of what we went through. Okay, so start with by the way, I'm Paolo Samontañez. As Marix mentioned, I'm one of the co-founders of OneWatt, where we use AI to diagnose what is wrong with electrical motors. So usually we detect, for example, when there's a bearing fault or if motors are about to explode, essentially. So that's what we do. So what is an anomaly? Are you familiar with this song? Anyone familiar with this song? Or am I too old? So the title of this song is Umaaraw Umuulan. So 'di ba in the Philippines there's kasabihan kapag umuulan habang umaaraw may kinakasal na duwende or tikbalang. Or depende kung saan ka nakatira baka it might be another creature. Because I think what happened here is that it's rare for us to see yung umaaraw habang umuulan. Most of the time when it's raining, we can see, diba, it's dark outside, cloudy. You can see the sun. It's kind of an anomaly for us if we describe yung umaaraw umuulan kasi it's not a normal occurrence. So if we define an anomaly formally, it is when the current observation deviates from the normal observations. So most of the time, pag umuulan, it's going to be cloudy. And it's special, it deviates if it's sunny while it's raining. So that's why it's an anomaly for us. So here in this slide, we can see, for example, in this time series graph, right? The one in red, the peak is much higher than the normal peak height. So that's why it's considered as an anomaly as well. Because compared to the rest of the population, it stands out, it deviates. And then the picture here of this gorilla, this gorilla is kind of special because it's kind of a rare gorilla. It's the albino gorilla. So it only happens like probably one in a million. And what's special about this is that it deviates again from the normal because normally gorillas are black, diba? So that's why it's an anomaly as well. And then if you if there are some data sets, for example, where you can see a lot of faces, and then within that population you see a dog, right? Then that dog becomes an anomaly as well because it is deviant from the normal observation. So keyword here is that deviation, and you have to keep in mind that it is based on a population. So you cannot say absolutely just by looking at a picture of a dog that it's an anomaly. You have to put it into a context. Where is the set of the normal samples? Because, for example, if I have a picture of the dog along with other pictures of dogs, then it is no longer an anomaly. So you have to put it into context that it should deviate from the normal observations or the normal population. So that's the important thing to keep in mind. Okay, so now that we've identified what an anomaly is, so now we can talk about how we can detect them. So the difficult thing with anomalies is that they can be very rare. So for example, it's not common for us to see, as I mentioned, the white gorilla, or the case where where it rains while it's sunny, diba? And some of the times, the anomalies that we encounter, it's very new for us. So we did not expect that. So at the point when we see it, it's completely unknown to us. So for example, ano ba? If you were ano ba? Kunyari, if you were the valedictorian and then you took a test and then it was the first time that you got like a very low score. So you parang before that you didn't know that you could actually do that. Parang ganun. So the unknowns might be completely foreign to you. So you have no idea of what that is. So that's one challenge. And then second, since we are predicting anomalies, there can be a huge range of anomalies. So for example, if we're talking about grades, for example, right? So we can probably the normal grade is around a mean or something, right? And then there can be people who score much higher than the mean or much lower than the mean. So that can be a type of anomaly. Already two types of anomalies. And then there might be an anomaly wherein it might not be caused by the student. Like for example, it might be caused by a specific question in the exam. There is no right answer, for example, in the test. So that's another form of anomaly that you cannot see, for example, just in that graph. So you need to take into account like other variables as well. And lastly, since anomalies are quite rare, it's hard to get data on them. So the occurrence of the actual anomaly, the probability of the existence of that anomaly is very close to zero most of the time. So that makes it very difficult for us to actually model who an unknown is given these characteristics. So given that, when you translate that into an algorithm, we encounter several challenges. So the first one, since it's very rare, the occurrence of the anomaly is very rare, we have a very low recall rate. Recall in AI is essentially the number of true positives divided by the number of observations of interest. So since the numerator is low, so basically the recall is proportional to that. So the recall goes down as well. So the recall is a metric for when you're designing AI systems on how good, for example, your AI system is able to classify true positives. So since we have a very low occurrence, then the recall drops as well. And then since we're dealing with unknowns, right? We tend to put in a lot of different variables into the anomaly detector, and that gives us an issue, for example, of a very high dimensional data. So it's easy for us usually to visualize 3D data, XYZ, and sometimes we can even add time. But when we're talking about like 4, 5, and even 3,000 dimensional data, it's already hard to visualize that. So that's a common problem here. Like for example, here in this graph, right? It's a 4-dimensional graph between for a motor, and then since it's hard to visualize already in 3D, they separate it into groups of two dimensions. So for example, how you read it is that so weight and then by displacement. So this is the graph of that. So since we're modeling unknowns at the time when we create the algorithm, we don't know yet what features would be the most suitable to detect the anomaly. So it might be by design that we want to include all the possible features and then later select which one gives us the best metrics for the AI. So this increases the complexity of the calculation or the algorithm itself, and it affects how good the anomaly detector is in general. And then last, since we're detecting very low probability events, it's very much affected by noise. Because for example, right, you can see the blue line here, that is the ideal, for example. But when we start taking observations, observations are affected by some sort of a random noise, a white noise. So you can see there's a bit of spike here and there when we sample this data. So now your algorithm must be able to differentiate a noise from an actual anomaly, because the noise is not an anomaly on itself, unless if your noise is, for example, it reaches a certain value and then affects your calculations. But yeah, later we can see how algorithms can be designed to make it more resilient versus noise when we do sampling. Oh, and lastly is explainability. So sometimes okay, so when we see for example yung umaaraw umuulan, sometimes we don't know what is actually happening. Like for example, we don't know, it doesn't tell us, for example, that when we see that occurrence, we don't exactly know if, for example, the pressure dropped to a certain value or the temperature increased at a certain value. So we cannot directly link the presence of an anomaly directly to a cause to it when we do anomaly detection. So that's one of the tasks that happens after we have detected the anomaly. So it happens post fact of the detection. Yeah, so actually this is one weakness of most AI algorithms right now, being able to explain why we classify something into a certain group. But yeah, later we'll go through some of the ways to alleviate this issue. Okay, so now that we've gone through the challenges, the question is, why should we implement anomaly detection if for example it's not explainable, it's very affected by noise, and it has a very low recall rate, right? So for example, what we're seeing right now, it doesn't really make sense until I tell you what it is. So for example, this picture shows the logins for specific accounts. And then if you can see which ones of these things look anomalous. So itong mga mukhang flowery patterns. Actually, what's happening here is that for each login account, the number of spokes is the number of login attempts from a different device. So for if you see a flowery pattern, it becomes a suspicious it becomes an anomaly for us. It becomes a suspicious pattern for us that why is this person logging in from multiple devices from multiple locations. So if we didn't do this, right, it's hard for us to visualize, for example, which accounts are being hacked at the moment, or we don't know we don't know what we're looking for yet. So uh using anomaly detection prepares us to handle uh, threats that we have not even encountered yet. So, for because for example, we didn't know that this can happen. For example, so that's one of the benefits of anomaly detection. And then the next, since uh, anomaly detection is quite broad if you think about it, since it's able to detect what is not normal, right, it becomes adaptable. So here in medical application, they trained it against the normal x-ray scans of lungs, and with the use of that, they're able to identify uh, different diseases that they are able to find in x-rays of lungs. But the thing is, they can only tell that there's something wrong, but they cannot tell what it is yet, until after, for example, the doctor gives them. But they know that there's an anomaly. So for example, the arrows here are pointing to the anomalous parts of the images. But at the point when the AI gave this data, they don't know what it is yet. It can only tell that there is something anomalous with 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 these scans. And then lastly, since we are able to do that, it's easier for us to collect all those anomalous samples. And later, if we decide to build a better AI to like classify directly without going through the anomaly detection, it's easier for us since we are able to catalog all the different types of anomalies that we encountered during the run of the anomaly detection. Okay, so now that we've established the difficulties and also the benefits. Oh, and also, by the way, I just researched earlier, the current market for anomaly detection is around $80 billion. So it's actually a growing trend right now in terms of AI. So you don't you it's most of the time it's actually the first step for AI companies who are adopting AI, because it's one of the most simple to implement and also the most flexible. So that's another reason for for adopting anomaly detection. Okay, so now that we've gone through those, so to get started, first you need to find suitable hardware. Most of the time, you will encounter algorithms that are computationally heavy. So that's a requirement. Although, well, if you are CS, right, you can always do a trade-off between memory and computational complexity. So later we will go through the spectrum of the memory heavy versus computationally taxing algorithms. And once you have that, be prepared to have huge amounts of data and a lot of cleanup with your data set. So just imagine if, as I mentioned, you can deal with data sets with 3,000 variables and then all through time. So usually if you're dealing with time series, right, you usually need at least a year's worth of data so that you can see the seasonality of seasonality of the patterns. So actually, we're quite lucky in the Philippines because we only have 2 seasons. But for example, if we're dealing with uh, the Netherlands, for example, or South Korea, where they have 4 seasons, the weather really plays a role in the fluctuations in in the data set. So actually, for example, since we're dealing with motors, right, and then some of our clients are in the gas industry, you can see that there's a huge drop, for example, when huge drop in the power consumption of the factories whenever we go to summer, and then there's a huge spike when we go to winter. So those things, if you're doing anomaly detection, you should be able to consider that. Otherwise, for example, those big drops or big spikes, they might be considered incorrectly as an anomaly. So be prepared to collect at least a year's worth of data and uh, multivariable data sets. So now that you have that in your disk inside your hardware, it's time to select an algorithm. So, okay, first algorithm that I picked, I think this is the most simple one. It's a distance-based metric. So distance here, so normally when we talk about distance, it is the Euclidean distance, right? So x squared plus y squared square root. And that's the distance for a vector, right? But distance here can mean different things. So there are other distance metrics, like for example, Hamming distance and the Manhattan distance, or you can even implement your own distance. But for simplicity of this, let's stick with Euclidean distance first. So the Cartesian in the Cartesian plane. The assumption here is that we can find a metric where anomalies will be far from its neighbors, but the normal observations will be close together. So to put that visually so that it's easy for us to visualize. So here you can see there's a lot of dots. So the dots correspond to a sample in the data. And each dot probably has around 3,000 variables along with it. And then we try to compress it into two-dimensional plane so that it's easier to interpret the data. Okay, so what we said is that we can find a metric wherein outliers are far from its neighbors, but the normal observations are close to each other. So you can see here I've encircled the the cluster of points where the points are close to each other. And then this arrow, we can see there are some points that are quite far from its neighbors. So if you use this algorithm, this would be the outlier part of the result of the algorithm. So the key here is that we define a metric. So actually, the metric here can be this is something that you will be doing by design. So here, our metric, it's actually a transform that we did. So we tried to compress the 3,000 variables into 2 dimensions. But for example, this can be temperature, and then this could be, for example, size. It's up to you to pick those variables. So this requires experimentation on that, which variables you would use as metric to so that it's easy for you to find the anomaly. So okay. So what is the advantage of doing this? One, it's very simple. We know the distance formula already, and it's easy for us to calculate the distance. So from here to here, we can just calculate the delta x, delta y, and then calculate the total distance. And then this is also well supported. There are a lot of libraries available that can help you to do this out of the box. especially if you're using Python. So that's that's very easy to find on the web. And then last is that it's an unsupervised system that is basically customized for the data set that you are running in. So the plot that you will see here will be different for every data that you give it. So it's very much dependent on that data, and it's essentially customized to the data that you put in. But the drawback is it is very computationally heavy, because later when we go through the algorithm, you will see why it's very heavy. And then it's also susceptible to noise, because a little movement to the left or to the right affects the distance already. And especially if you're dealing with huge amounts of data, right? The 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 deviations can cause the distance calculation to have a misfire or a false positive. And then the last item here, the curse of dimensionality. You'll hear this quite often actually when you're doing anomaly detection. So what does this mean? So when we were looking at the graph, we were only looking at 2D, right? X, Y. But imagine if your data is in higher dimensions, like 3D, 4D already. And then so if you're doing 2D, diba, you can see X and Y. And then if you add the third dimension, uh, there's one more degree of freedom. And then the more you add, the more dimensions you add, the more degrees of freedom, right? And then, for example, if you have 100 points, 100 data points, if you put them into the graph or the chart, the distances become of those points become too far to each other, especially if you're in higher dimensions. So for example, if you have 100 points in 100 dimensions, most probably your points will become equidistant to each other. That's an issue, because if we're talking about distances, if the distances are all uniform, then the algorithm will have a difficult time finding that differentiator of how can we define an anomaly. And then you have to also to consider that as you get more and more dimensions, you increase the computational complexity of the algorithm. So if we're talking about 2D, it's x squared plus y squared. But as we go into higher dimensions, it becomes x squared plus y squared plus z squared plus n sub 1 to the n sub 1 squared, and it becomes longer as you get more and more dimensions. So it increases the amount of time for you to process the whole data set. So that's the curse of dimensionality. Okay, so typical, as I mentioned, it's a well-supported algorithm, right? So typical algorithms include DB outliers, K nearest neighbor distance. I think this is one of the most common. I think you should have heard of this already. And then yeah. For now, I'll be showing you this DB outlier. So actually, okay, just to take note, DB here is distance based. So later there's another DB, but it's density based. So I just placed the distance here. So how does this algorithm work? So for example, in this plot, I've placed 1,000 points. And then we want to check if this point here is an outlier. So from this point, we define an R. This is something that we tune depending on our data set. So from that point up to an R radius, we count the number of points that fall into that circle. And then we define a P percentage wherein if at least p% of the points lie greater than, so basically outside this circle, then it is an outlier. So for example, here we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of, let's just say that this is 1% of the, for example, if we have 1% here, so the rest, the points outside is 99%. So if we decide here, if we put p as 99%, then this point is an outlier. Compare it to this point. So for example, this has 10% of the points. So the percentage outside would be 90. So it didn't reach the 99% level, right? So it is not an outlier by definition if we use the distance-based outlier. And it is computational heavy because for every single point, so for example, from here, we need to calculate the distances of each point. So imagine going through 1,000 points to calculate the distance from here to point sub n. So you need to do that for each sample. So as your dataset grows, it becomes more and more computationally heavy. So that's the drawback of as we discussed earlier. Okay, so now that we know that how distance-based anomaly detection works, I can give you one example, for example, here, wherein we have, instead of having one cluster, there are two. And then additional challenge is that the cluster here is more dense than this. So it's hard to find. So in theory, you don't want to rule this out as an outlier because they may be normal samples. It just so happened that the variables have a greater distribution. So they are normal, but they are more distributed over this dimension, for example. So here, it's hard for us to actually find a combination of p% and r such that we don't rule this group as an outlier. So that's one of the difficulties when you're using the distance-based algorithm. So to combat that, we have the second algorithm, which is density-based. And the assumption here is that normal observations should have a density similar to its neighbors. And then conversely, an outlier will have a density very different to its neighbors. So as you can see here, right? So these points have relatively the same density. So they should be normal. And then this one has also kind of a uniform density. So it's normal. But when you reach the edges, this becomes an outlier because the density here of this point is different from the density of its neighbor, which is here, which is very dense. So the advantage of this, as I've mentioned, it handles the scenario wherein in your data set you have clusters wherein they have varying distributions, so varying density essentially. And disadvantage here is that it's even more computationally heavy compared to the distance-based. So sorry, this is density-based. And it's even more susceptible to noise because we are dealing with the density already. So it takes into account the average of average distances. So that has a big effect on that. And then last, it's also affected by the dimensionality. So imagine if you're taking distances in higher dimensions and then taking the kind of a derivative of that, which is density. in higher dimension, it becomes very complex. So to illustrate how you do this, okay, so we try to simplify it by using lower number of points, right? So for example, this is our point of interest. We want to see if it is an outlier or not. So from this point, we decide on a value k. So for example, in this case, we use 2. We get its 2 nearest neighbors. So these two points. And then from here, we get the average distance between point P and its k nearest neighbors. So for example, here this is 2 and then this is 2. So the average is around 2, right? So the average distance from this point to its k nearest neighbors is 2. And now from its k nearest neighbors, we try to get the k nearest neighbors of those points as well. So since we're dealing with 2, right, we should be getting 2 as well. But special case here is that this is the first this is the first nearest neighbor, but these two are equidistant to this point. So we are going to get we are getting the 2 nearest neighbors, but we got 3. So essentially we will be averaging 3 points since they are equidistant. So the distance from here, the average distance from here to its nearest neighbors is, so this is 1. This is square root of 2. So that's the average of that. And then same scenario here. So if you compare 2 versus something 1.1 or something, you can see that there's a difference in the distances between the density of the points. So it's up to you to decide what is the acceptable ratio, the threshold, what an outlier is. But basically, you can derive that by comparing the ratio, for example, from here 2 versus 1.1 something. So that's how you define an outlier using the density-based algorithm. So far we've been discussing algorithms that are usually done in 2 dimensions, the XY plane, and they are both affected by the curse of dimensionality. So how can we have an algorithm that is resilient to this? So what we do is usually we use something like a generic feature learning. So essentially we use features in the dataset that has the greatest effect on the definition of the anomaly. So when we see the data, we don't know that yet, but we will use AI, for example, to help us identify which features have the greatest effect, and then we will be using that on future feature samples. And then since we are using deep learning, we're able to adapt based on the data set. So if you have 3,000 dimensions, but only 2 of those features are useful for our purpose, right? The system should be able to home in those and then use that for the prediction. And then lastly, we try to reduce the computational complexity because uh, the algorithms that we've shown earlier, right? They are the computation required grows as your dataset grows. So we want to have a model that can handle that easily. So given that, we go through the third algorithm, which is predictability modeling. So the assumption here is that normal observations are more predictable uh, if you look at its previous states. So for example, going back to the example of, for example, these are the the grades of a student in exams, right? So there's probably, this is the mean, and then there's a standard deviation, right, of the scores. And then you see here that there's a sudden dip in the scores. So it 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 feels like there's something wrong, right? When you see a student having like a strange score in one of their tests. So we can define this difference between the predicted value. So predicted value should drop somewhere in this box versus the actual as the error score, or how anomalous the observation is. So that's how this predictability modeling works. So we try to predict where the next point will be, and then we calculate how far the actual observation is, and then we decide what threshold we should use uh, to to classify that as an anomaly. So the advantage of this technique is that, one, it's very supported as well, uh, with, especially in Python or even in other language. Uh, it works on high dimensional data without issues, and then this is very much well suited for time series. So usually we're dealing with samples in the time domain, right? So this is very much fit for that. And as a bonus, we get the ability to forecast. So we can predict future values using this technique as well. But the disadvantage is that we need to have data that is periodically sampled. So it will affect if it will your model will be affected if your data set is sampled at different time intervals. I mean, different frequencies, different sampling rates. So for example, on the first month you sampled once a day, but on the second month you sampled every hour. So that will affect the model in terms of accuracy in the prediction. And then second, it's sensitive to outliers in the data. So actually, if you put in outliers in the training, it might think that it's a normal occurrence. So that will greatly affect the accuracy of the model. And then uh, we did the sacrifice of trading computational complexity to memory consumption. So this algorithm is relatively consumes much more memory for that, because we need to keep in mind what the previous values are in 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 the time domain. And then lastly, the issue of the explainability. We 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 can tell that there something is wrong, but we don't know what happened. So typical algorithms for this, LSTM, long short term memory for AI, and then uh, ARIMA, which is autoregressive integrated moving average. This is actually one of the most famous uh, time series prediction algorithm. So if you're going into electrical systems, so this is the most common algorithm they use to predict, for example, power consumption. How much power should we generate, especially sa Meralco. And then uh, the rest are variations of how you predict future values. But for this, I'll be showing LSTM. So LSTM again, long short-term memory. So if you've encountered neural networks, right? This is one type of block in a neural network. And what's special about this block is that it has a memory. So it's easy for us to remember the n previous samples, for example, that might affect the output. So the actual output is affected by the previous values and the output of the previous block. So it it makes it perfect for time series prediction because as we've said in the assumption, we think that the future value is affected by most the nearest previous values. So for this algorithm, we will be using this type of block in the AI. Okay, so to use it, there are two steps to this. The first part will be the training, and then the second one, the inferencing. So to train it, you chunk your data set into the time series equivalent. So you have multiple versions of this, multiple inputs, and then you put them into that LSTM, and then they will give you an array of values. And during training, you since you created this time series, right? Then you know what the next values are. So those are the observed values. So for example, here, let's say 3, the next 3 values here would be this. And then we compare the predicted values by the LSTM and the observed value, and we get the difference. And then we try to minimize that difference by doing the gradient descent. So it's a continuous loop until we reach a certain accuracy. And once it's trained, this model will accept the new observation, and then it will churn out another prediction, and then we input the actual values again, and then we decide on the threshold. So for example, if we say 0.5, that's already high, then we classify that as an anomaly. So as an example, for example here, I've inputted this time series into the LSTM, and then this blue line here is the prediction, and then this is the actual value. So as you can see, this is the error, the height difference between the points from here to here. That's the error value. So it's up to us to decide what level of threshold would be for deciding this as an outlier. So that's how you that's how you identify outliers using the predictability modeling. And then lastly, the next algorithm is autoencoder. So the assumption here now is that normal observations can be reconstructed with less features. So imagine, I've mentioned earlier that we have 3,000 features to define a sample. But it might be that only 5 of those features have an effect on the system. So what an autoencoder does is that basically, given a sample, we try to reconstruct it, and then we try to get the total error between the original and the reconstruction. So for example, for each pixel, we calculate the error, and then we sum all the errors as a total reconstruction error. And then this is the metric that we use to identify whether it's an outlier or not. So the advantage of this is that, again, it's very much well supported in the community, and it also works on very high dimensional data. It's actually one of the best algorithms to use for high dimensional data, and it works on almost any type of data. So it doesn't have to be a time series. time series data for it to work. So that's another good thing. And then additional benefit is that it is able to compress data in a lossy way. So it's a lossy compression. And lastly, another side effect is that it can remove noise from samples. But the drawback is that bias can bias in your data can make irregular infrequent patterns uh, in the final output. So if it can make it such that if a regular pattern does not appear that often, it might be seen as some sort of an outlier. So you need to make sure that you have a good spread of your data on on all possible values or scenarios. And second, in terms of complexity to tune, it is a bit more difficult to 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 tune the parameters of this type of algorithm, and it requires a lot of data to train so that you can remove the bias. And then last, it's the lack of explainability as well. So typical algorithms, the vanilla autoencoder, and then there's a variational autoencoder, and you use these different types of autoencoder depending on your type of data, and if you want special features incorporated uh, into the network. So usually you use variational autoencoder if you want to ensure that if you want to limit the set of possible outputs, for example, for reconstruction, by taking into account the the distribution of the data. So it depends. But for now, we will be using I will be demonstrating the vanilla autoencoder. So to do this, there are again two steps: training and then the inferencing. So during the training, you get multiple samples, and then you pass it through the encoder, which reduces your data into, let's say, 4 dimensions. So here, for example, this is if this is a 100 by 100 image, so you have 10,000 pixels, right? And then we compress it to say just four variables. So that's the job of the encoder, to reduce the dimensionality to 4. And then the decoder would try to upscale that back to a 100 by 100 image. And then you will go through several iterations, for example, wherein, yeah, as you can see, it doesn't really match. And then up to here, for example, because during the training, we get the differences between the image and its decoded reconstructed version, and then we update both the encoder and the decoder until we reach a certain accuracy, like here, for example. So what does the encoder and decoder look like? So usually it looks like this. So for example, the typical neural networks, right? Most of the time they are symmetric, but it's not a constraint. You can have a decoder that is more complex, for example, and that's a different type of autoencoder. But most of the time, you will try to make it symmetric. But the thing here is that the decoder has no uh, connection to the encoder. So it will try to figure it out how to reconstruct on its own, just given these two inputs, for example. So they should be working independently. And then what we have here in the middle is what you call the latent space representation. This is the reduced dimension version of your input. So for example, from the 10,000 pixel thing, right, we reduce it down to 2. So this is if you're compressing your thing, this is what you use. So once you have that trained, you pass an image to the network, and then it will churn out a picture, and then you get the difference between each pixel, and then you get the error, and then it's up to you to decide what value for that error you would classify as an anomaly. So that's it. So now that that's the last of the algorithm that I'm going to present, and now we're going through the applications. So typical application. Okay, so actually this is one interesting for healthcare. Uh, Basically, they tried to measure the variability between the heartbeats, the the time it takes for each heartbeat, and then by doing that, they are able to identify anomalies in the heartbeat. This is useful for people with heart disease, or I forgot the name, angioma or something. But basically, where they skip a heartbeat. So that might be this might be very useful for those kinds of diseases, right? Where it can cause death, for example, if you miss several heartbeats. And then another application is that try here in South Korea. Actually, this is something that they're implementing here. Is that they are detecting motor anomalies based on power consumption. As you can see here, right, there's kind of a pattern in the power consumption here in this plot. But there are times when you expect a peak, but there is none. So this plot here is the error. So they're using the predictability modeling. So this is the error, right? And then once they're able to find that, then they can warn, for example, the plant manager to check what happened with the motor. Why did it skip uh, this operation? And then last, for OneWatt, right? Now we're trying to detect anomalies in pipes as well. So for example, here we can see the spectrum of a normal pipe, and then this is the spectrum of pipe with a leak, and then yeah, this is a different type of leak. So before we didn't know this is what a leak looked like in the frequency domain, but with the use of what do you call this? The autoencoders, we were able to catch the frequencies that are affected by leaks, for example. So yeah. So in conclusion, if you're just starting your journey to identifying something, anomaly detection is a good start. Especially if you are not sure of what you are interested in. You just know that there's something that's going to go wrong. So anomaly detection is the way to go. And second is that you need to choose the right algorithm based on your data set, how you want to threshold your anomalies, and lastly, requirements. So for example, if you don't have time, then you should use an algorithm that has less computational complexity, so it's easier for it to finish. And lastly, anomaly detection is usually the first step, but it's not the final step. So it's good for you to implement this so you can catch all the anomalies and then collect them. And then later on, it's easier for the future AI engineers or other analysts to design much more complex AI strategies to detect specific types of problems. So just keep in mind that this is not the final form of your fault detection system. So yeah, so that's basically it. If you have any issues or if you need help with your modeling, you can contact us here or contact me here at power@onewatt.eu. So yeah, thank you very much.
Ayun.
Are we getting questions?
Hello?
Hello?
Yep. Hello?
Yeah,
Yeah. So do you have any more questions for Paolo? Actually, I think you can ask, in the light of his talk, I think you can ask any any questions like related to AI that could probably help you with your future career. So if you're shy, you can put it in the chat box.
Or you can email us.
Yeah.
as well.
Yeah. Anyone from the from our participants who would like to take this opportunity to
The first one is an anomaly kasi yung normal set hindi nagko-question eh.
yeah, that's probably they're just amazed on what they have learned
Baka
Sure.
medyo
today.
overwhelmed, Miss Linda. Baka medyo
Yes.
overwhelmed po sila.
Yeah.
So ano ba? Yun po.
Varied kasi yung ating participants ngayon. We have from different programs, Associate in Computer Technology, BS Computer Science, BS Information Technology, and BS Entertainment and Multimedia Computing, and from different year levels, from first year to fourth
Okay.
year,
I see.
yung
I
mga
see.
participants natin today. And I do hope anyone from our especially yung ating mga fourth year students who would like to take the opportunity to have a career in AI.
Baka po yung teachers may questions din po kayo. Actually, Paulo is actually an AI engineer. So if you want to be, an AI engineer someday, maybe you can also ask him questions. So don't feel free to ask.
Or if you're shy, you can just email us. Yeah. We're
Hello
very
po.
much
Like
happy to help.
to
Sorry?
yeah.
Good afternoon po. Naririnig po ba ako?
Yeah, we can hear you.
Okay po. My name nga po pala is Mase A. Bautista. I'm from BSCS 1A. First year student po ako. May tanong po ako regarding dun sa time series data. Since nakaka-capture po siya at regular time intervals, pag po ba hindi nakaka-capture pa rin po ba siya regardless of that?
What do you mean naka-capture? Nasa store sa database or yung
parang
algorithm?
Whenever it happens po ba na ka-capture pa rin po natin yung data doon sa time series data po natin regardless of the time interval?
Okay, so if you have a varying time yung sampling interval for your data, what I suggest is you go with the lowest common sampling rate. So for example, you drop your samples. If you have, for example, mas mataas yung sampling rate sa if mas mataas yung sampling rate, for example, here in this area, then you remove some of them so that it matches this. Because what will happen later on, if for example the interval here is 1 month nga, and then dito is 1 hour, and then you input this into the LSTM, it will assume that everything is the same interval. So that will cause an error later on your predictions. Did I answer your question?
Yes po. Thank you po.
Yeah. So actually, this is one of the typical cleaning processes when you get your data. So that's ensuring that they are common. They have a common interval, and also you might want to, for example, normalize your values so that your values don't go from 0 to infinity, because that if you have a more defined range, it's easier for the AI to figure out the transform that it needs to do.
Okay.
Thank you, Pao. Thank you to the student who asked a question. Actually, can you chat your name again? Sorry, yung nagtanong kanina.
Mahasya.
Bautista. That is a first year.
Wow,
BSCS
first year.
student.
Impressive naman. Okay, mukhang
interested
Mm-mm.
with an
Oo
AI
nga
cartoon.
eh. Sige. Actually, to be, of course. Actually, OneWatt is usually, well, we are always looking for interns, actually. So, for those who want to work for a Dutch company, as an intern, or maybe baka, malay nyo maging part kayo ng engineering team ni
We posted
Paolo.
an AI job posting, diba? Recently.
Yeah, we did. We did. Actually, nasa
we are looking
Facebook
for
namin
AI
siya. Nasa
engineers.
fan page. We're also looking for AI engineers. So, and front end developers. So, if you want to work for Pau, well, under Pau.
Mm.
So, we're also
That
looking for
means
interns.
you could possibly entertain
Yep.
OJT and
Yes, we do. Actually,
near
we do.
future.
Pero of course, it's virtual kasi the company is
Mm-mm.
based in Arnhem. So, yun po.
Ah,
Actually,
okay.
depende naman po sa dean kasi I think we had one intern. She canceled her internship with us because her school doesn't allow students to join foreign company. So, pero andyan naman si Miss Linda, so I'm sure madali lang yung approval.
Oh naman, I would really take advantage of that for our students.
Yes.
Actually, yung aming mga BSCS and BSIT fourth year will be having their OJT next semester that will start ng January to May. So I
Yeah,
hope
mag-apply.
any of those students would be interested, especially the BSCS fourth year
Yes.
students natin.
Yep. Sige po. Ayun, sige. So,
Ma'am Marix, may question yata sa
as a chat ba?
chat
Wait,
box. Oo.
Ayun, Pao, may question. Ayan. So, from Gmail Roque. So, by cleaning the data, do you mean remove some data or get the average of that data set? Pao.
Okay. It depends. It varies. So I wouldn't disregard the averaging, but most of the time, the easiest is to, as I've said, yung deleting the data. That's one way. There are other times that it requires more sophistication. Na you need to find data that you need to delete. So for example, here the one I demonstrated earlier, it's quite easy because it's just based on the sampling rate, right? So parang skip counting lang tayo. Let's delete one after the other, for example. There are times when cleaning is very, very difficult. So actually, if you get, for example, if you get a data dump from your clients, some of those data will become invalid. Like for example, okay, one actual use case that happened to me quite recently. So I got a data dump from one of our clients, and then what we were monitoring is the noise level or the sound coming from their microphones. And then I trusted the data initially, so I just fed it into the network, and then we didn't get good results. But when I looked into the data, for a specific sensor, it returns, for example, a flat line for all the values. Pero for example, the variable we are monitoring nagfa-fluctuate ng malaki. So when I asked them about this, right, and then they looked into it, so apparently one of this sensor, that specific sensor, was broken. So yun, that's why it was returning a flat line for all samples. And then that affected the future training because I inputted this faulty data into the data set, into the training. So the cleaning of data, it there's a huge possibility of actions that you will be doing. So it can be as easy as deleting samples. It can be finding, for example, these error scenarios, which can be again different for each sensor. And then sometimes when it can also be that when you're cleaning data, you try to segregate them into equal what do you call this? Equal distributions. So for example, when we are classifying between anomalous and non-anomalous, right? So or a specific state, we want them to be balanced. That's another type of cleaning. So there's a huge number of cleaning steps that we can implement. Yeah, and it's dependent on what is needed by the AI, essentially. Did that answer your question?
Oo. Mukhang nag-thank you na siya. So, okay. So, we'll
So
entertain the
it's
next
an exciting
question.
thing. So every time you receive a data, it's a surprise. So parang si Forrest Gump nga, di ba? It's a box full of chocolates. You don't know what you'll get.
Sige, I think we should entertain the next question. So this is the second to the last question. Okay, so this is from Nathaniel. As ko lang po, being an AI engineer, ano po ang mostly na-encounter nyo na problems?
What do you mean by problem? Problem
Oh,
ng client or
deployment
problem developing an AI
sa
system?
development. Feeling ko, kasi as an AI engineer. So,
Sige.
baka sa development.
For me, the most the what do you call this? The problem I think most about is how should I model the client data? So for example, yun nga, if I'm receiving, for example, an image, I cannot use, for example, LSTM for this. And then what other algorithms can I use to process this? So the way you handle data or the way you process data will be different depending on the type of data they have, and also what is the mix of their data. Like if they're asking me to detect something or to predict something, how frequent is it that we see the combination of those different states? So that's kind of the most common problem that you have to think as an AI engineer. How do you model your data? Okay.
So I hope I was able to answer. So it's really how to model the client's data. Ayan. So actually we have two questions. So sige, let's entertain Mr. Justin's question first. So regarding the development of AI, how much time is allotted for development and publishing of the program? Do you have any kind of solutions when it comes to the huge computational processing? Are there any kind of proposals on how it could be lessened? Ayun.
Okay. When I started doing AI development, I was using my laptop na I think that was 2014 model, and that was around 2017 that I started. So I had a hard disk, yung rotating hard disk pa, tapos mga medyo lumang video card. So each iteration of the training took probably around mga 45 minutes. Tapos fast forward to now, I'm using a laptop rin, pero right now I'm using a GTX 1070. If I run the same training, right, each iteration only takes a fraction of a second. So it's very dependent on the hardware that you are using. So yun nga, if depending on the algorithm you use, it will have an effect on how long the calculation is. Pero just try to get the average of, for example, when you start a new model, try to get a metric of how fast each iteration is, so you can estimate how many cycles you need to reach a certain value of accuracy. And in terms of the training time, this is actually, we spend a lot of time in training, but one of the features of OneWatt is that we have an application that helps us tune the AI much faster compared to normal people, so that reduces a lot of guesswork, and also it shortens our training time. So I think that's one of our advantage compared to our other AI competitors. And but if you're on the average, if you're not using that, it can range from a couple of hours to days actually. So actually, okay. So if you can hear some noisy fan sa audio ko, it's because I'm running another training that I've been running for 3 days already. So I'm able to reach uh, an error of a 4. So I'm measuring the millimeter in the millimeter range, right? So I can predict up to 4 millimeters yung error, but right now I can't go below 4 millimeters. So I'm still training it until now because I'm hoping I can reduce the error up to 1 millimeter. So it becomes ano ba, asymptotic. So after you reach a certain level, it becomes harder and harder to reach a more ano ba, more accurate state, for example. But it's something that you should discuss with your client and what is the minimum acceptable level, for example. But in terms of range of time, it can range from hours to days, for example, or even longer.
Okay. Ayun, sige. Actually, madami na yung questions. Nakakatuwa naman. Sige. So, let's entertain lang. Okay pa ba pa schedule mo? Kaya pa naman, diba? Sige, okay. Sige, there's a next question. Sige, actually, thank you for answering, Pao. So, I hope, Justin, I hope I was able to answer your question. So, feeling ko naman, you can email him if you feel like kulang na yung sagot niya. Okay, so let's entertain Jester's question. So, what kind of algorithm needed to translate
Google
Translate.
Translate. Okay.
Such as Google Translate. Ayun.
Okay.
So,
magdodrawing ako dito. Sige.
Go lang.
Okay. The bare bones for this solution requires at least 2 parts. Here, yung LSTM, but before you input LSTM, so your input, well, let me draw. Your input to the LSTM would be the words, for example. So, for example, I am Paolo. So this will be the input to the LSTM. Yun yung default. But to make it better, instead of inputting words, we introduce one more step here, which is called an embedding. What it does is that for each word, so for example, yung I, we come up with a vector space or an array representation of a word na puro numbers lang. So for example, this is an n size array. Each of these will have a value depending on the word. And what will happen is if you have a similar word, so for example, we, the distance between the vector of I, the embedding of I, and the embedding of we is close to 0. So that's how you judge how similar the words are. So the first part would be generating the embedding of words, and then instead of using the actual words, we input their embeddings. So yun yung input, and yun yung, instead of words, you use the embeddings, and then you compare it with, for example, the translated version of the exact phrase. So for example, I am Paolo. If we were to translate it in Korean, Jonun, Paolo, mas mahaba pala siya. Paolo Imnida. So 1, 2, 3, 4 words, right? So the input will be the English version, and then you will be outputting an an embedding, and then you will be comparing that with the translated version. And then the goal of the model is to come up with the transform that will produce this the transform to this sentence such that yung yung output here would have a very similar embedding. And then now it's easy for us to actually get which is the equivalent of the embedding of similar words, are the distance of the embedding of similar words should be close to 0. So now we can get ano yung equivalent of each word by comparing their embeddings. Malabo. It's a very simplified version of it, but yeah, that's basically, so 2 parts: the embedding process, and then the use of the LSTM to compare the translated and the base language.
Okay. So, mukhang nasagutan mo na. Sumagot pa ba siya? Let me check na. Yeah, I think so. Yeah, you were able to
If hindi ka satisfied, just we can talk
email
much
pa.
further.
Oo. Sige. Okay, so let's entertain another question. So I think this is very basic. So do you recommend using TensorFlow as the first step for beginners to learning AI development? So actually, Pao, do you recommend yourself to, like, for beginners, do you recommend them to use tools, branded tools, to learn AI?
Feeling ko
Or
biased yung sagot ko kasi I'm a Google fan. So,
sige.
sabihin ko yes, TensorFlow. TensorFlow is the best.
Okay.
Pero yun nga, it doesn't have to be TensorFlow agad. If you are a Python developer, there are a lot of Python libraries out there. Actually, if you use SciPy, there are already a lot of AI tools already na hindi neural network. So for example, the distance-based modeling, that's already available in SciPy. And then there are a lot of other libraries out there na non-TensorFlow. So it's up to you which algorithm you want to use. But if you want to go into neural networks, then TensorFlow, I think, is the easiest to learn.
Yun, the bias po si Sir Pao. The joke lang. Hindi, sige. Okay lang yan. Ayun. So that, I guess the answer is yes. And then, sige, next question from Neil Arais. In developing an AI, does it need some high standard hardware to have a better performance? I think yes.
No. I would have to disagree on. This is
Okay.
something that you need to a lot as a developer. So if you know that your computer is slow, then you need to just probably a longer time for training. And also, there are ways to improve your computational efficiency. So either you improve your algorithm. So for example, if we're dealing with distance-based algorithms, right? Teka, let me pick another screen. So sige, balik tayo. Okay. So for example here, right? Kanina we were computing distance from each point to all the points, right? But if for example, if we want to increase the computational efficiency, we can improve it, for example, by adding several other algorithms. So for example, we can do bucketing. So for example, here we can just calculate. We can put all the all the dots into kunyari yung buckets na yan, and then we don't need to calculate for ano ba, for all the points, kasi we only know hanggang saan ba yung bounds kunyari nung circle na to, only within these buckets, and then we only need to count how many fall into these buckets. So that significantly reduces the amount of computation you need in terms, but you're sacrificing memory. So mga tipong ganun. There's always a trade-off between different types of algorithms. So you can improve that. And also, second option, actually, you can even do trainings or actually hindi trainings. You can do AI inferences in Raspberry Pi. So there's a special version of TensorFlow, for example, Raspberry Pi. But don't expect a lot. But it is possible at, for example, medyo low end na hardware, which is a Raspberry Pi. So it doesn't have to be the best, but you need to take into account what is your computational speed and your algorithm.
Okay, sige. Ayun. Hindi man pala kailangan. Sige. So yes, I guess that's the last question. Sige, may gusto bang humabol? Wala na. Mukhang okay na. Sige, actually, if you have questions, you can email or, yeah, you can email Pao. Yan, nakita mo yung screen mo kanina. There. So please email Pao at OneWatt.eu. And then if he doesn't reply, you can message us on Messenger. On our fan page. So ako nang bahala mag-nudge sa kanya if you did email him. Ayun. So I think that's it for today. I thank you Gordon College for accommodating us. Actually, Pao is going to do another similar talk actually on October 26th. So we'll actually parang follow us on our fan page. We're going to announce it there. So yeah. Yun lang. Thank you, Miss Linda. Thank you to the faculty of CCS. Thank you for accommodating us.
Yes.
Yun po.
I think kami yung dapat magpasalamat for OneWatt for sharing your expertise to our students and our faculty members. And I hope you were able to inspire them to take a career in AI. Okay. Sana po.
Hopefully.
And yeah. So, my dear students, I think you really need to somehow enhance your mathematical skills as suggested sa akin kanina ni Ma'am Marika. Kailangan hindi porket nasa computer kayo, akala nyo maglalaro lang kayo. There really need to focus to enhance your mathematical skills, your logical skills, and then focus also on studying algorithms. Yan ang ano. Kasi AI really is not anymore the future of computing. It's now. It's really the need now ng ating industry ng it's all over us right now. So better consider that and probably specialize on some AI strategy for your future careers.
Yep.
Okay? Sige, Ma'am Marika and Sir Paulo, baka meron pa kayong last words for our
Meron pa kaming pahabol request. So, Pa wants to take a group picture sa ating 202 audience. So,
Yes.
actually, hindi ko sure kung paano siya gagawin. Pa, kaya mo ba sa ano mo?
Wait,
screen
actually
mo?
ako marunong. Wait lang.
I can handle it po. I can handle it. Sige po. Just please stop sharing po yung ano nyo.
Okay.
Stop na lang po.
Stop sharing.
And then do it.
Para we'll have
Okay, so our dear students, please open your camera. Our guest speaker is requesting for a
class picture.
Yeah.
Magre-report po kami ni Pao sa
picture,
boss
nice
namin.
One.
Yes.
So yes, you can also use our virtual background too. Yes, Ma'am Linda.
Kaya nga, take this opportunity to have a group pic with our resource speaker, and malay nyo when you venture into an AI career, maging employer nyo si Sir Paulo.
Ma'am, sana Sir Paulo and Ma'am Marika, sana mas matagal, no? Ma'am Linda, tama ba? Mas matagal.
Baka if there would be more
it's like a series, mga ganon.
Yeah. We're planning to do that as well. Actually, if you have suggestions on topics that you want to learn, you can tell us. So especially about AI, so we can prepare for that. So actually, our difficulty is coming up with the topics. So if you can help us on that,
nice.
yeah.
Wow. Anyway, let's have muna, Zoomy Pics. Sige. Okay,
so
first page.
Not basically anomaly detection, but any AI. Pwede,
yung
sir.
Most requested na topic.
Okay. Sige, sir. We'll be working on that.
Okay, so Zoomy Pics muna tayo. First page tayo. Okay, 3, 2, 1. Again,
guys,
1, 2,
thank you very much for everyone who attended. Thank you for taking the time to listen to our resource speaker. Okay, and keep safe always, ha? And also, I would like to take this opportunity meron na tayong we were given the chance ng ating local government unit to be vaccinated, yung ating mga Gordon College students, mga college students natin, binibigyan na ng opportunity ng ating local government unit to be vaccinated. So may mga schedule na po tayo. I hope everyone would participate on that kasi that's our preparation for our upcoming face-to-face classes. Okay? Para lahat tayo safe pag nag-conduct na tayo ng face-to-face. And I know all of you are missing that. Especially yung mga first year and second year students natin na hindi pa namin nami-meet personally because of the pandemic. Sana kayo yung unang-unang magpa-vaccine para pag nag-open na tayo ng ating face-to-face, ay ready kayo lahat and everyone is safe. Okay? So again, Sir Paulo and Ma'am Marix, maraming salamat po for providing us this webinar, and hopefully looking forward to more topic discussions. Especially, it's really a great learning if you hear experts to be discussing topics they are really good at. So yun yung naman we do not encounter this on our daily classroom management. Kaya being able to invite resource speakers who are really experts on their field, malaking opportunity na po sa amin sa academe. So again, maraming salamat po, and to everyone who participated, thank you very much, and hopefully we will have another set of AI topic discussion from Sir Paulo. Okay,
Sure.
thank you.
Okay, thanks. Bye, everyone.
Sir
Thank
Joseph, kayo po
you.
yung nag-picture kanina? Ay,
We will
sige,
share it with you.
Yes, ma'am. We'll send it to your email, and then before, actually we prepared the closing prayer para sa before tayo mag-bid ng goodbye sa mga students natin and to
Yes.
one of our partners sa OneWatt and from Sir from OneWatt, represented by Sir Paulo and Ma'am Marica. Sige po. This closing prayer will be led by Sir Arnie Armada.
Sir Arnie, nakamute ka yata.
Ma'am, ipi-play natin.
Okay. Sige.
Actually, hindi siya yung file extension niya hindi ma-view. So, I'll play it sa Google Drive. Yeah. Ano muna tayo? Again, thank you so much, Sir Paulo. Well, I'll just iba kasi yung file format, so hindi binabasa ni Zoom.
Okay, sige. We'll wait so that we would be blessed.
Yes, of course.
Ay, Miss Linda,
Sir,
sige. Ay, next time. Chat na lang.
Heavenly Father, as we come to the end of our time together in this webinar, together we thank you for what has been accomplished here today. May the matters discussed by our excellent speaker serve as a catalyst to move us forward and cause us to advance and see growth in all areas of our lives. May you give us the grace to hear your voice and the strength to continue working for your kingdom. May you give us the courage to accompany and side with those who suffer amidst this pandemic. May we leave here recognizing you are the God of all wisdom and you are willing to lead us forward. By your grace, you who are rich in mercy, bring an end to this pandemic. Give us your peace and fill our hearts with unflinching faith in your protection, hope in your help, and love for you and our neighbor. This we pray in the name of our Lord Jesus Christ. Amen.
Okay, so again, maraming salamat uli po to everyone and looking forward to more collaboration with OneWatt and Miss Marix. Thank
Pwede
you.
po. Sige, Rise of the Machines 3, Miss Linda, let's do it again.
Okay,
Sige
no
po.
problem.
Thank you po. Thank you, pa.
Thank you.
Thank you, Ma'am
Thank you,
Marica,
Sir
Sir
Paul.
Paulo.
Bye.
Thank you.